Hey, boys and girls, welcome back to another edition of Think Different Television. Oh yeah, okay, so we're doing transformations and we're doing dilations today. Ooh, what are dilations? Well, a dilation is a transformation. And transformations are all kind of things. They're a reflection, a rotation, a translation, or a dilation. So all these things are called transformations. So it's like an umbrella term, in which the image may be a different size than the pre-image. So for all of these we just did, the image and the pre-image are congruent. But now with dilations, they may not be congruent, but they are similar. So a dilation requires a center point and a scale factor. Okay, so we're looking at that as we do it. So what are the scale factors? Let's see. So R is what the scale factor is in this case. So these are the different kind of scale factors. Copy this down, and this down, and this down. There's a little box of scale factors. So pay attention to this part because we're going to do a little quiz in a second. So if R, the absolute value of R, absolute value means the distance away from 0. So if the absolute value of R is greater than 1, the dilation is an enlargement. If the absolute value of R is between 0 and 1, which means like a fraction, the dilation is a reduction. It gets smaller. So if R is 5, for example, it enlarges. If R is negative 10, because the absolute value of negative 10 is 10. Or if R is 1.5, because that's greater than 1, those are all when the shape enlarges. Between 0 and 1, so that would be like 3/4 between 0 and 1, or like negative a half. 0.5 is a half, right? So these are examples of when the shape might shrink when you have a scale factor like that. And if absolute value of R equals 1, then the dilation is congruence transformation. So nothing changes, essentially. It just doesn't enlarge, it doesn't reduce, it just stays the same. Okay, let's see if we can do it. Yeah. Okay. Enlargement, reduction, or congruence transformation. Here you go. So here are 8 different scale factors. We're going to figure out whether the shape is going to get bigger, going to get smaller, or going to stay the same. So copy these down. All right, cool. I'm going to do the first couple, and I have my eyes on my notes. Got my eyes on my notes right here. This is going to help me. Eyes on my notes. That's how we take notes. So here we go. So if R equals 3, that's when the absolute value of R, which is 3, because 3 is 3 from 0, is greater than 1, so that means that this is an enlargement. The shape is going to be 3 times as big, so the image is going to be 3 times bigger than the pre-image. Okay, I'm going to do this one. So absolute value of R in this case is just 0.75, because 0.75 is 0.75 spaces away from 0, so this is going to be between 0 and 1, because that's 3/4, that's not 0, that's not the whole thing, that's a part of it, so this is a reduction. So the shape is going to be reduced by 3/4, the size, if I have a scale factor like this. How about this one? What do you think this is going to be? Woo! Yeah, this is a reduction. All right, last one, and then you're going to do it on your own. This right here, so the absolute value of this is 1.01, because negative 1.01 is 1.01 space away from 0. So that is greater than 1. I'd rather have $1.01. That's more than just having $1, right? Pac-Man is the bigger man, so this is an enlargement. Not by much, but it's going to get a little bit bigger. All right, try this. 5, 6, 7, 8, go. Woo! All right. This is going to be between 0 and 1, so this is a reduction by a half. This right here, ooh, the absolute value of R is 1, so this is a congruence transformation. Nothing changes, it just gets the same thing. So it just stays the same. So if this is the pre-image, that's the image, it's the same thing. Nothing changes. This looks like a fraction, but it's actually not. The absolute value of r is positive 3 over 2, which is, that's greater than 1. That's actually 1.5, which is an enlargement. That's how it's going to trick you. It looks like a fraction, but it's actually more than 1. It's an improper fraction. This is between 0 and 1, so this is a reduction on number 8. Hopefully you got 4, 5, 6, 7, 8 correct. If not, fix it on your paper. There we go. Okay, so let's try one, shall we? Okay. Back to this. I'm going to do 2, you do 2. So, find the image. Sorry, can't see it. Find the image after a dilation centered at the origin, okay? So, that's the center of the point. Just like you're rotating around the origin, this dilation is centered around the origin, it's going to change. Just like rotation has changed, but make sure it says origin first so these rules apply. With the scale factor of 2 and then a scale factor of a half. So we're going to take these points and we're going to do scale factor of 2 over here and a scale factor of a half over here. So we're going to do it twice. Okay. So notice how my y-axis is kind of bigger than my x-axis. It's going to be necessary for this problem. So we got j, which is 2, 4, 1, 2, 3, 4. So it's j at 2, 4. Label these with me. K is 1, 2, 3, 4. 1, 2, 3, 4. K is 4, 4. And P is 1, 2, 3, 1, 2. So P is 3, 2. So here is our pre-image, this triangle right there. Okay. So now my scale factor is 2. So what am I going to do? I'm going to multiply every coordinate by 2. So J prime, 2 times 2 is 4. 4 times 2 is 8. So J prime is 4, 8. You just doubled, I multiply by 2, both coordinates. So K prime, 4 times 2 is 8. 4 times 2 is 8. Cool. What's P prime going to be? Yeah, 3 times 2 is 6. 2 times 2 is 4. So let's graph it. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So here's J prime, 4, 8. K prime is 8, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's K prime, 8, 8. And then we have P prime, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, right? So we're overlapping with this K prime. Okay, right here. It's just regular K, and this is going to be P prime, which is 6, 4. So, there you go. So notice how this is 2 times as big right here. So like this is 2 spaces. This is 1, 2, 3, 4. So each side is double the length. So these are similar. Similar right there. They're not congruent. They are similar. So here's the image. There's the pre-image. All right. Next, let's do the same thing, but now we're going to do a reduction by a half. This is an enlargement by 2, so let's do a reduction. So same points, so J is 2, 4, 1, 2, 1, 2, 3, 4. Here is J, which is 2, 4. And then we have K, which is 4, 4. And then we got P, which is 1, 2, 3. 1, 2, wait, this should go up here. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 1, 2. Yeah, that looks like that. Gotta make sure it looks like that. Okay. So P is 3, 2. There is my same pre-image right there. Okay, so now P prime, a different P primes, it's a different problem. So if P is 3, 2, rather than multiply by 2 like we did for the first time, we're going to take half of it. So what is half of 3? So I have $3 and I give you half. What do I have? Yeah, $1.50 or 1.5, $1.50. Half of 2 is 1. And then I have Let's do k. Let's go backwards. K prime in this case. Half of 4, or divide by 2. 4 divided by 2 is 2. 2. What is j prime going to be in this case? Yeah, 1, 2. Take half of both those numbers. Okay. This is what I'm going to do on the graph. So p prime. Can you have a decimal? Yeah, you can. That's okay. So it's 1 1/2. So you go 1 1/2 on the x like that, then you go up 1. So there is p prime. Like that. P prime is 1.5 and 1, and then k prime is 2, 2, and j prime is 1, 2. There you go. Connect the dots. There you go. And here is your image, which is twice as small. So like this side is 2, and half of 2, this side is 1. And whatever this side is half, the corresponding side. Got it. Cool. All right. Now your turn. Here you go. So dilate about the origin. So same rules apply. In this drawing, I want a dilation of a scale factor of 2. And in this one, I want dilation of scale factor of 1/2. Here are your points, D, G, and F. Ready, set, go. Okay, in this one, D prime is going to be -4, 0. G prime is going to be 0, 4. And F prime is going to be 4, -4. Got it. Now when my scale factor is 1/2, D prime is going to be -1, 0. G prime is going to be 0, 1. And F prime is going to be 1, -1. And then you graph, and you can see the scale factor at play. Good work, everybody. Nice job.